Okay, let us discuss these reactions. These are quite easy reactions. You have to write down the product in this case. So this is the dehydration of alcohol. You have to write down the product in this case. Can you write this one? Quite easy one. So what you have to do? You have to first attack H plus, lose H2O, primary carbocation, rearrange the carbocation and lose H plus again. So let us see the solution. What you will do? You have this fun. First you add H plus, you will get H2O, release H2O molecule, so this is minus H2O. If you release one molecule of water, you will have a carbocation that is primary in nature, so this is 1 degree carbocation. And now if you do hydride shift, you will have carbocation here. Now in the next step you lose H plus from here. If you lose H plus from here, you will have a double bond here, so this is the double bond. Now this will exist as a cis and trans form, so you will have, this will have basically cis as well as trans, both will be the form, cis as well as trans both. And I know trans is generally more stable, so in this case trans product will be the major product. Are you getting on? So cis will be the minor and trans will be the major product. Now this question, let us do the next question. If you have written this one, those who have not written, let us write, and those who have written, and let us do the next problem. This is again easy problem. Dehydration of alcohol, H plus heat. Generally dehydration can be done in the presence of H2SO4 and heating. You can also do dehydration in the presence of Lewis acid like PCl5, BF3. You can also take alumina, Al2O3. This all does dehydration if the sufficient heating is given there. So if you have alcohol, either you treat with H plus, either you treat with PCl5, or you treat with Al2O3. These are basically Al2O3, PCl5, BF3 can also used as a dehydrating agent for dehydration of alcohol. Finally we will have a alkene. So let us write in this case what the product you are getting. Again you have to make a carbocation, methyl shift, loss of H plus. That's enough hint. So let me see the solution. So you see, in the first step what you are doing is you are generating a carbocation. If I make H2O plus and lose H2O plus, I will get a carbocation here. Now if I do methyl shift, I will have something like this. Then if I lose H plus, I will have this. So this will be loss of H plus. If I lose H plus, I will get this. Are you getting or not? If you understood this one, quite easy one, let us do the next one. Again this one is an easy problem. You have Ag plus and iodine minus. So first you will have Ag plus will take I minus and it will form precipitate. And then if you have a carbocation, so you see there are many ways by which I can generate a carbocation. And finally you will have alkene. You can have alkene by dehydration of alcohol. You simply see alkyl halide is treated with Ag plus. Again it can generate alkene. So let us write the product in this case. Okay, so you see the solution. So what will happen? In the first step, Ag plus will take I minus. So I minus goes from here with this bond pair and forms AgI. So you will have a carbocation here. Now you will have a methyl shift. If you do methyl shift, you will get a carbocation that is a tertiary in nature. So initially it was secondary in nature. Now you are getting a carbocation that is tertiary in nature. In the next step, if you lose H plus, you will get an alkene. Now this time there is this alkene cannot exist as a cis or trans because CH3 both are the same group. So for cis and trans to be exist, these two groups should be different. Are you getting or not? Again these two groups should be different. This can be C1, C2, C3, C4, different groups should be there. Maybe one group on this and one group on this may be same or may not be same. That is not always true. So you can have four groups, all four groups are different, or you can have a two kind of groups here and two the same kind of groups here, or you can also have a three kinds of group, 1, 2 and 3, and this group may match either with this one or this one group. It cannot match with this group. So on the same carbon, you cannot have two groups of same kind. That is the important thing for to exist geometrical isomerism. So what is the condition for geometrical isomerism is, on a carbon you should not have same kind of two group. That is the NF condition. If this is fulfilled, that there are no two groups that is same type, then it will show the geometrical isomerism. So let us discuss the next problem. I think you have written this one. This is related to, so this problem is related to formation of carbocation and loss of H plus and generation of an alkene.